Okay, today we are starting our logic series, which focuses on conditional statements. This is going to be really important for forming how we support our conclusions and write our next set of proofs that we're going to be doing, which are two-column proofs. So, in class we read If You Give a Mouse a Cookie to kind of give you a familiar memory to relate if-then statements to, and then syllogism, which is when we're pairing all of these conditional statements together to follow logic and draw conclusions. So let's start with some vocabulary first. So a conditional statement is any statement written in if blank, then blank form. So sometimes we have this in complete sentences with words, and sometimes you're going to see this symbolically. So we're just going to have letters. So this reads if P, then Q. So that arrow is telling us that this is a conditional statement. So our conditional statements have two parts, the hypothesis and the conclusion. The hypothesis is the phrase following the word if, but not including the word if. So in a proof, this would be kind of stating what we're given. So our P. And then the conclusion is the phrase following the word then. So in our conditional statements with proofs, this is going to be what we are proving, or our Q. So let's look at an example here. We're going to underline the hypothesis and circle the conclusion in the statement. If it rains, then the game will be postponed. So if it rains, the hypothesis is the phrase following the word if. So that would be it rains. And our conclusion is the phrase following the word then. The game is postponed. So that's your P and that's your Q. It's not always going to be P and Q, but that is kind of our standard way of kind of like X and Y are the most common used variables for our conditional statements. P and Q are our most common letters, but there's other ones you can use as well. Okay, so there's our hypothesis, there's our conclusion. You can also rewrite statements as conditional statements by putting them in if-then form. So if your hypothesis, then your conclusion. So in this example, two straight angles are congruent. So I need to turn this into an if-then statement. So my hypothesis would be if I have two straight angles. So if two angles are straight, then what do I know about them? They are congruent. And again, I'm using shorthand with my symbols here. It's totally fine if you do that as well, just to save on space and some writing. Okay, so what can we do with these conditional statements? So our conditional statement, that's our original if P, then Q. Well, we can take the converse of that statement by swapping the conclusion and hypothesis. So that would be if Q, then P. We also have the inverse, which is where we would say not Q, then not P. That symbol, that squiggly, is negation. That just means not. So our inverse is if not P, then not Q. And then the contrapositive switches the order and negates both. So if not Q, then not P. And then your original conditional statement and your contrapositive have the same truth value. And what that means is that it's just true or false. So if your original conditional statement is true, your contrapositive is also true. If your original conditional statement was false, that means your contrapositive is also going to be false. Okay, so let's look at some examples of writing our converse, inverse, contrapositive. So here's an example of a conditional statement. If you live in Fort Worth, then you live in Texas. So my hypothesis here is you live in Fort Worth. That's like our P. And our conclusion is you live in Texas. So that's our Q. So remember, the converse is Q, then P. So it just switches the order. So in this case, this would be if you live in Texas, then you live in Fort Worth. Now, let's talk about this. So on the first statement, this conditional statement, if you live in Fort Worth, then you live in Texas. That is a true statement. Now, my converse, if you live in Texas, then you live in Fort Worth. Is that always true? And the answer is no. And I know this, why? Because I can name several other cities like Austin or Carrollton or Dallas or Louisville that are cities in Texas but are not Fort Worth. So those other examples that prove this is false, those are called counterexamples. So I know this is false because of the counterexample and then any other city in Texas that's not Fort Worth. Okay, so that was our converse. Now our inverse is if not P, then not Q. So if you don't live in Fort Worth, then you don't live in Texas. And again, I know this is false because of many, many counterexamples. El Paso, Houston, Galveston, etc. Okay, let's look at our contrapositive now. So I'm going to switch the order and negate both. If you don't live in Texas, then you don't live in Fort Worth. This is also true. Okay, so my conditional statement and my contrapositive were both true. So whatever the truth value of your conditional statement is, your contrapositive will have the same. Okay, so let's practice some law of syllogism, our chain of reasoning. What this tells us I can do is if I have a series of if-then statements, conditional statements, that relate to each other and flow, I can draw one final conclusion starting with my initial hypothesis and my final conclusion. So here, for example, if P then Q then R then S then W, that means if I'm starting at P, I can use and follow this chain to say if I'm starting at P, my final result is going to be W. So your conclusion would be your initial hypothesis with your final conclusion. So this is our chain rule. And this example up here was in the order. It all flowed together, but that's not always how it's going to be. So sometimes we have to either rearrange our symbols or sometimes read through our statements to determine the correct order and follow the logic. So let's start with example 1. If G then R. Well, R is not the next one, so I'm going to start rewriting this off to the side. If G then R. Well, then R takes me to J, and J takes me to D, and I've got one statement left. If T, then G. Well, that one doesn't follow along at the bottom, but that G is at the top, so I know that T, then G is going to be my starting statement. So if I'm following my law of syllogism, if I start at T and I go along my chain rule, I'm going to go from G to R, then R to J, and then J to finally land at D, which means my final conclusion is going to be if T, then D. All right, let's look at example 2. If not X, then Y. If P, then Q. If F, then not Y. If X, then not Q. Okay. I've got a couple things here that don't quite match. I've got a not X and an X. I've got a Y and a not Y. And I've got a not Q and a Q. So what I need to do is rearrange some of these statements so that I can follow a flow and my statements do match. So the way that we do this is by taking the contrapositive, because remember the contrapositive has the same truth value. We can't change the truth value just so that we can make our statements flow together. We have to keep the same truth value. So if I want to rewrite this first statement, if not X, then Y, and take the contrapositive, remember that's going to change the order, so if Y, then X, and it negates both. So that would be not Y, and when you negate something that's already negated, it becomes affirmative, kind of like a negative times a negative. So this is going to be rewritten as if not Y, then X. Okay, so I've rewritten that, which means this statement, if F, then not Y, those can go together. Okay, so I'm kind of piecing it together. I'm going to cross off what's on my list and start doing some elimination. I've got, okay, here, if X, then not Q. And so my last statement that I haven't touched is if P, then Q. But what I have here is not Q. So in order to get this to be not Q but keep my same truth value, I need to take the contrapositive. So that's going to switch the order, Q, then P. Broke my pencil, and negate both. So if not Q, then not P. So now I've pieced all my statements together, starting at my initial hypothesis. If I follow my chain of reasoning all the way to the final conclusion, that's going to tell me that if F, then not P. Okay, so those were examples with symbols. Let's look at some ones with words. So starting on number 3. If gremlins grow grapes, then elves eat earthworms. If trolls don't tell tales, then wizards weave willows. If trolls tell tales, then elves don't eat earthworms. So what I'm going to do is rewrite each statement using a symbol just for ease of piecing it together. So let's say this. If gremlins grow grapes, then elves eat earthworms. If G, then E. Okay? Then if trolls don't tell tales, I'm going to say that's not T, then W. Wizards weave willows. Okay? Then if trolls do tell tales, then elves don't eat earthworms. Okay, so I've got my 3 statements. Now again, I need my symbols to match. So I've got a not T and a yes E, and then a yes T and a not E. So I'm going to take the contrapositive of this final statement so that they now match. And if I put them in the correct order, G then E, and then not T then W, my initial hypothesis is going to be G, and my final conclusion is going to be W. So if gremlins grow grapes, then wizards weave willows. Okay, so I've got this final statement here, or final problem here with some statements, and not all of them are written in if-then form. So what we need to do first is rewrite them in if-then form, and again, we can rewrite them with symbols first, and then put the letters back in later. So smart people make a lot of money. And an if-then statement, that would be, if you are smart, then you make a lot of money. So let's say if S, then $. If you're smart, then you make a lot of money. Mrs. Varner is a geometry teacher. If you are Mrs. Varner, then you are a geometry teacher. If you lead an exciting life, then you are not boring. If you lead an exciting life, then you are not boring. If you read a lot, then you are very smart. If you read, then you are smart. Geometry teachers are boring. If you are a geometry teacher, then you are boring. If you live a dull life, then you read a lot. Okay, so let's try to piece these together. If I have a dull life, then I read a lot. If I read a lot, then I'm really smart. If I'm really smart, I make a lot of money. Dull life, dull life. I'm running out of things that go together here. Let's see. If you lead an exciting life, then you are not boring. If you lead an exciting life, then you are not boring. This, not B, and I've got an affirmative B here. If I take the contrapositive of this, if you live a boring life, then it is not exciting. That can help take care of some stuff, right? So, let's see what else we got. D then R, Varner then geometry, Varner then geometry, geometry then books, books then not exciting. Would an equivalent to not exciting be dull? So if you live a boring life, then you are dull. Okay, boring then dull. So that takes care of all of my statements. So if you're Ms. Varner, you teach geometry. If you teach geometry, then you're boring. If you're boring, then you live a dull life. If you live a dull life, you read a lot. If you read a lot, then you're smart. If you're smart, you make a lot of money. So if you are Mrs. Varner, then you make a lot of money. That would be our final conclusion. And that is it for our notes on logic and conditional statements.